This lesson is about segment relationships in circles. So there's three types, but it's really more like two. So we have when two chords intersect inside of a circle. So if I'm intersecting inside, I've broken my two chords into four total pieces. So what I'm going to do is I'm going to take the two pieces of one chord and I'm going to multiply them. I'm going to get rid of this word inside here. I'm going to put what I'm actually doing. A times B equals the other two pieces multiplied, C times D. So the formula for this is really piece times piece equals piece times piece. The two parts of one multiplied equal the two parts of the other multiplied. Both of these are outside of the circle. If I look at where the two lines cross, they cross outside of the circle. So for this first one, it's two secants. The second one is a secant and a tangent. I'm going to take A times A plus B and set that equal to C times C plus D. So what I really did here was I took the part that was outside and I multiplied it by the whole thing. So outside times whole. And then that's going to equal on the other one outside times whole. Which if I'm looking at this one here, outside is A and the whole thing is A. So I could really write that as A squared. But the other side is still B times B plus C. Outside times whole. So even though this one doesn't look exactly the same as this, we're going to still use the same formula of outside times whole. It's just that for this segment, the outside part is the whole part. So for our first example, I have along one chord x and 10, so x times 10 equals the other chord. I have 14 and 15, so 14 times 15. So it's going to be 10x equals 210. Divide by 10, we get x is 21. The next example, same idea, but now I want to solve for BD. So after I find x, I'm going to plug it back in. So that's going to be 4 times 5x minus 1. I'm going to make sure I put parentheses around the 5x minus 1 because it's talking about both those parts, the 5x and the minus 1, equals, on the other one, we have 6 times 6. So I'm going to distribute. So we have 20x minus 4 equals 36. Add 4. 20x equals 40. Divide by 20. X is 2. So if I take that 2, we have 5 times 2 minus 1. 10 minus 1 is 9. And we're looking for all of BD. So 9 plus 4 is 13. All right, let me combine some stuff here so you could try it all together. All right, you try both of these. For the first one, solve for x. For the second one, solve for TQ. Pause when you're ready to see the answer. Hit play. All right, so for the first problem, we have 27 times x plus 5 and 24 times x plus 7. We get x is 11. For the second one, I have 18 times 2x minus 5 and 14 times 2x plus 1. We get x is 13. And when I substitute that back in to find TQ, 2 times 13 plus 1, TQ is 27. So our next problem now is an outside problem. So this is outside times the whole thing. So what I tend to do is before I get started, I will figure out what the whole length of each side is, if it's not already given to me. So here I'm going to have to add together the 9 plus x, and I'm going to usually put the variable first, x plus 9. And here when I add 8 and 19, I get 27. So now when I do outside times whole, on this segment, the part that's outside is 9, and the whole thing was x plus 9. For the other segment, the part that was outside was 8, and the whole thing was 27. So we're not actually using the parts that are in here. We only use them to find out how long the whole thing was. So I'm going to distribute. 8 times 27 is 216. Subtract 81 and divide by 9. So you try this one, pause. When you're ready to see the answer, hit play. All right, so the part that was outside was 13. The whole segment was x plus 13. The part that was outside was 10. The whole segment was 52. So we end up with 13x plus 169 equals 520, and we get x is 27. For our next example, this is one of the ones where the part that's outside here is also the whole thing. So the outside is 16, the whole thing is 16. Here the outside is 8, the whole thing is 5x minus 1 plus 8. So minus 1 plus 8 is plus 7, so that's 5x plus 7. So for outside times whole, we have 8 times 5x plus 7 equals, the outside is 16 times the whole thing is 16. So distribute, we get 40x plus 56 equals 256. Subtract the 56, 40x equals 200. And divide by 40, we get x equals 5. You go ahead and try the next one. Pause. When you're ready to see the answer, hit play. All right, so outside was 18, whole thing was x plus 18, outside was 24, whole thing was 24. So we end up with x equals 14. All right, so this is still outside. There just happens to be x's on both parts, so that's fine. So if I add this together, 9 plus x plus 3, 9 plus 3 is 12, so that's x plus 12. On this side, 6x minus 1 plus 7, so minus 1 plus 7 is plus 6, 6x plus 6. So outside is 7 times whole thing is 6x plus 6 equals outside is 9 times whole thing is x plus 12. So now we're going to distribute twice. I'm going to subtract 9x from this side. I'm going to subtract 42 from this side. Divide by 33, we get x is 2. So you go ahead, try this one. Pause. When you're ready to see the answer, hit play. All right, so the part that was outside was 6, while the whole thing was 2x plus 18. The part that's outside was 10, while the whole thing was x plus 13. So we end up getting x equals 11. So for the last ones, I have an x all by itself over here. So outside is x, whole thing is x. And on the other side, outside is 27, the whole thing is 21 plus 27, or 48. So if we're doing outside times whole, x is outside times x is the whole equals 27 is outside times 48 is the whole. So x times x is really x squared. 27 times 48 is 1296. So here I'm actually going to take the square root of both sides to get x alone, and we get 36. So So you go ahead, try the last one, pause. When you're ready to see the answer, hit play. Okay. All right, so 8 is outside, the whole side is 50. X is outside, the whole side is x. So when we do x times x equals 8 times 50, we get x squared is 400 and x is 20. And that is everything on segment relationships in circles.